Let's talk about internal resistance real quick. Here's our nice little circuit. We have a potential established, and we've got 3 resistors, and here's our battery. But here's a real battery. Now, this real battery exists here, but it doesn't have a, what's this kind of thing got? It's got, oh shoot, what did we say? It's 1.5 volts on there. There it is. So it says, all right, 1.5 volts. Oh, what am I doing? There we go. All right. So now, when I put it in here, this battery is actually, a case that looks like this. And then this is the low potential side. And there's a rod that comes down the middle like this. And this is the high potential side. And then there's the case that goes across the top. And then inside of here, you've got some battery junk or whatever. So really, this is what's happening. And as we connect this through our resistors, and as my little charges move through the circuit, they're resisted by this, they're resisted by this, they're resisted by this, and they have to physically make it through this kind of mess. So we have some sort of resistance of the battery. So the way that we put that into this setup is by now drawing it like so. So this battery has an EMF and an internal resistance. So now this now turns into, here's my EMF of 1.5 volts, and then I have an internal resistance, and then that then goes to resistor 1. Actually, I should do it in this one. Resistor 1, resistor 2, resistor 3. So in my setup, here my series circuit, my total resistance, my equivalent resistance is going to be the internal resistance plus resistor 1 plus resistor 2 plus resistor 3. And so when I talk about the voltage, that is actually the terminal voltage. That's the voltage that exists between here, right here, and right here, which on my drawing exists here and here. So the terminal voltage is the EMF minus the voltage drop across my internal resistance. Now granted, these internal resistances are small, but they are not insignificant.